Welcome student in your favorite channel Alchemy N. So I think you remember in the last period what we have taken. So I think we have taken merits of Mendeleeves periodic table. Today we are going to start demerits of Mendeleeves periodic table. So total 4 demerits of Mendeleeves periodic table are given in our textbook. If you see on the page number 20, the same demerits they have given. So you can refer page number 20, demerits of Mendeleeves periodic table. Let me tell you one thing. Demerits, it is also called as drawbacks. Okay. In examination, instead of demerit, maybe drawbacks, this word they can use. Drawbacks of Mendeleeves periodic table, demerits of Mendeleeves periodic table, the meaning will be same. Let us start. So first drawback of Mendeleeves periodic table was the whole number of atomic mass of element cobalt and nickel is the same. The atomic mass of cobalt and nickel is the same. Therefore, there was ambiguity, little bit confusion regarding their sequence in the Mendeleeves periodic table. So this is the first demerit. What we are understanding from this, the atomic mass of cobalt, atomic mass of nickel, it is found to be same. Now, where the place is cobalt? Where is the place of nickel? So for places of cobalt and because their atomic masses are same, therefore there is an ambiguity regarding with their sequence in the Mendeleeves periodic table. So this is one of the biggest drawback related with cobalt and nickel. So first drawback we have seen related with cobalt and nickel. Second drawback they have given, isotopes were discovered after long time after the Mendeleeves. Okay, the isotopes were discovered after long time of Mendeleeves. As isotopes have, we are knowing that okay, isotopes have same chemical properties but different atomic masses. This we are knowing. Isotopes have same chemical properties and different atomic masses. But a challenge was created related with isotope, placing them into Mendeleeves periodic table. So you know isotopes were discovered long time after the Mendeleeves. Okay. So the isotopes having same chemical properties and different atomic masses, different atomic masses. So therefore there was a challenge where these isotopes were placed in the Mendeleeves periodic table. So about their position, some challenges was there. Okay, so this was the second drawback. Third drawback, when the elements are arranged in the increasing order of atomic masses, this we are knowing Mendeleev, he had arranged all the elements in the increasing order of atomic masses. The rise in the atomic mass does not appear to be uniform. The sequence he arranged the element in the increasing order of their atomic masses, that sequence we can say the rise in the atomic mass does not appear uniform. Then what happened? Therefore, it was not possible to predict how many elements could be discovered between two heavy elements. The rise in the atomic masses was not uniform. Therefore, it was very difficult to find out in between two elements how many elements are present. So this is supposed to be third demerit, drawback of Mendeleeves periodic table. And the fourth drawback, let me tell you, regarding with the position of hydrogen. Okay, 3-4 points are there. This is the big drawback, demerits of Mendeleeves periodic table. Position of hydrogen. What about position of hydrogen? Hydrogen show similarity with halogen in the Mendeleeves periodic table. If you observe group number 7, in the group number 7, okay, halogens are there. Which are halogens? Let me remind you, halogens are chlorine, bromine, iodine. Okay. Hydrogen show similar property with the halogen, means chlorine, bromine, iodine. The property of chlorine, bromine, iodine and hydrogens are same. For example, molecular formula of hydrogen is H2 and molecular formula of fluorine is F2 and molecular formula of fluorine is F2. Means molecular formula of fluorine F2, chlorine, Cl2, hydrogen, H2. Means similarity. There is a similarity in the molecular formula of hydrogen, chlorine and fluorine. Point number 1. Then point number 2, there is a similarity in the chemical properties of hydrogen and alkali metal. Okay, there is a similarity in between chemical property of hydrogen and alkali metal. Alkali metal like sodium, alkali metal like potassium. The chemical properties of sodium and potassium and chemical properties of hydrogen, both are the same. So hydrogen actually plays in the first group. Hydrogen first shows property similar with the group number 7. Then again hydrogen shows chemical property with same chemical property with alkali metal, means group number 1st. So little bit there was confusion that where is the place of hydrogen in group number 1st and group number 7. Then next, still demerit is going on. There is a similarity in the molecular formula of compounds of hydrogen and alkali metal formed with chlorine and oxygen. On considering above property, it cannot be decided whether the correct position of hydrogen is in the alkali metal or correct position of hydrogen it should be given in the group of halogen, means in the group number 7. So this is the drawback. From the hydrogen, from the properties of hydrogen compared with group number 1st, compared with group number 7, it was not decided that where is the correct position of hydrogen in group number 1st or in group number 7. So today total how many demerits we have seen? Total 4 demerits we have seen. So 4 demerits you have to see from page number 20, it has been given. You have to read this property, means demerits properly. Demerits of Mendeleeves periodic table, and you have to prepare one short note, because this demerits of Mendeleeves periodic table, it may go for 3 marks because it is a long question. Write a short note on demerits of Mendeleeves periodic table. Okay. So in the last period we have taken some revision. So today also we will take revision. Just today we have finished demerits of Mendeleeves periodic table. Okay. Now this was the remaining point, because here the Mendeleeves periodic table finish. From tomorrow we are going to start a new point from this lesson. But okay, some revision is needed. I think in the last period we have taken a revision of Demerits triad. In today's period we will take some revisionary points from the Newland's law of octave. So the name of Newland, you are knowing, John Newland. Okay, the year in which John Newland he had carried out his work related with law of octave near about 1866. Okay, how Newland's arrange his element. Okay, 56 element he arranged, that you have to know. Okay, you should know that. Okay, 56 elements it were arranged by the Newland. So Newland arranged his 56 element in the increasing order of their atomic masses. This you should know. Okay, then let us compare element. According to Newland's law of octave, if we see the table, octave table, it is given on page number 17. Properties of fluorine matches with properties of hydrogen. Then properties of sodium, means element number 8. Properties of sodium matches with properties of lithium. Properties of magnesium matches with properties of beryllium. Properties of aluminium matches with properties of boron. Properties of silicon matches with properties of carbon. Properties of phosphorus and nitrogen are the same. Properties of sulfur and oxygen are the same. And one thing we have seen in the last lecture, that Newland's law of octave is related, applicable up to which compound? So that compound is calcium. Up to calcium, this Newland's law of octave is limited. After calcium, this law does not become applicable. Okay. Then totally how many element Newland classified? Just we have seen before 1 minute. Total 56 element Newland classified. Okay. What is the Newland's law of octave? This is very important, because after studying, students are saying, sir, what is Newland's law of octave? So let me tell you. Newland observed that properties of eighth element and properties of first element, these are similar. So he observed these properties of eighth and first element, that is the similar, and he called that law of octave. Whatever his observation was there, properties of eighth element, properties of first elements are matching. So this observation is called as law of octave. Generally, this question will be asked, what is the law of octave? So you have to tell that, okay. Newland observed that properties of eighth element and properties of first elements are matching. Okay. They are matching with each other. The properties of eighth element and properties of first elements are similar. So that is the law of octave. Okay. So this is some revision we have taken related with Newland's law of octave. Hope today it's a time to stop in today's lecture. But tomorrow, once again, the new point we will take, that is from this lesson, new point we will take, that is the modern periodic table. So without missing tomorrow's lecture, you have to join. Tomorrow modern periodic table we are going to start. This is very important point, quite a prolonged point. Okay, keep watching and please subscribe my channel Alchemy, and thank you all of you.